Hello, this presentation is about operating systems, specifically the process manager and its role in scheduling. You may be asking, what is scheduling? Scheduling is the activity of the process manager that handles the removal of the running process from the CPU and the selection of another process on the basis of a particular strategy. In other words, it decides which of the processes in the ready queue is to be allocated to the CPU. So why do we need scheduling? It maximizes system throughput, is fair to all users, provides tolerable response, degrades performance gracefully, and is consistent and predictable. The criteria for scheduling are priority assigned to process, class of job, resource requirements, whether it is I/O or CPU bound, resources used to date, and waiting time to date. If scheduling is preemptive, the scheduler removes a process from the processor so another process can run, while if it is non-preemptive, a process only stops running if it has terminated or incurred an I/O wait. Throughput: number of processes completed per unit time, turnaround time, time between completion and submission, waiting time, total waiting time in ready queue, response time, time between submission and first response. The scheduling policies are first come first serve, shortest job first, priority scheduling, round robin, multi-level queues, and multi-level feedback queues. With first come first serve, a process that requests the CPU gets it first. It is implemented with a FIFO queue and is non-preemptive. This is bad for time-sharing systems and disastrous when there is a large process at the head of the queue. In shortest job first, the processes from the ready queue are organized based on estimated runtime or CPU burst. It is a priority scheme and primarily non-preemptive. The shortest processes are dealt with first. With priority scheduling, different internal and external criteria are used to determine which task goes first. It can be preemptive or non-preemptive. This may lead to the problem alluded to earlier of starvation. Increasing priority or aging is used to deal with this. Round robin is where the CPU is allocated to a process based on the time slice or time quantum. It is necessary for a time-sharing system. The process is interrupted and sent back to the ready queue. Preemption occurs at the end of the time quantum. With multi-level queues, the ready queue is divided into several queues, but processes do not move from queue to queue. Multi-level feedback queues are different from multi-level queues because there is feedback between queues so that processes can move from queue to queue. Processes are placed in queues based on CPU bursts. Aging is used to move low priority processes to high priority if they wait too long. This has been a presentation on scheduling.
Created using Powtoon.